Good day, guys. We are looking at another problem on linear programming from Maths Level 4. So we'll go through that. And again, these are the key statements that will help us. When you read the question, look out for statements like maximum, and the meaning is less than or equal to, at most, the same thing, not more than the same thing, and the last three are opposite of the first. Minimum is greater than or equal to, at least is greater than or equal to, and the same thing will not less than. So we'll go through the problem. A group of farmers intend to sell X bunches of spinach and Y bunches of carrot at a store. They can have at most 400 bunches of spinach. So you see, when I read that and mark out my keyword at most 400 bunches of spinach, spinach is represented by X, and at most 300 bunches of carrot, which is represented by Y. So there should be at least, these are the key statements, 450 bunches of both. Both now means you take X plus Y in the store. And then the ratio of spinach to carrot must be at least 4:5. So that is it. So you can now go to the questions. The first one says, two of the constraints are X greater than or equal to 0 and Y greater than or equal to 0. So write other constraints in terms of X and Y. So we're going to do that here. So those key statements are underlined. That is where we'll focus. The first one says they can have at most 400 bunches of spinach in our table. At most is less than or equal to. Spinach is X. So I'll be having X is less than or equal to 400. That's my first constraint. Then the other underlined statement is at most 300 bunches of carrot, that is Y. Again, at most is less than or equal to. So get Y less than or equal to 300. Then there should be at least 450 bunches of both items in the store, which means X plus Y. So X plus Y at least is now the opposite of at most. At most is less than or equal to. At least should be greater than or equal to. So greater than or equal to 450. Now coming to the tricky statement, the last sentence says the ratio of spinach to carrot must be at least 450. So we know that spinach is X, carrot is Y. So when we talk about the ratio, this is how we started. The ratio of spinach is X to carrot is Y, should be at least, the key sign there is greater than or equal to 4 is to 5. So another way of writing ratios is to write them as fractions. So I'll say Y over X, X over Y, is greater than or equal to 4 over 5. Then from here, I will have to take the LCD. The LCD is 5Y and multiply the two numbers of the denominator and use it to multiply the left and the right. So if I multiply this one by 5Y, it's like you multiply this side by 5Y and that side by 5Y. So that will tell you that Y will cancel Y. So on the left, I'll get 5X is greater than or equal to 5 cancels 5, I get 4Y. So I always prefer putting Y on the left hand side. So if 5X is greater than or equal to 5Y, that will therefore mean that 4Y is less than or equal to 5X. Just like if I'm older than you, then you are younger than me. And from here, I can divide both sides by 4. So my constraint is 5Y less than or equal to 5 over 4x. So 4 main constraints here are 1, 2, 3, and 4. So those will be my constraints in the A part of the problem. So the tough one is usually this one of ratios, and that is how you handle it. And it's good to put it with Y on the left so that when you go to draw, you don't struggle. Then the B part says with a profit of 4 rands. Profit of 4 rands is made on each bunch of spinach. You know spinach is X, and 3 rands on each bunch of carrot. current is your y. So we need the profit equation. So the b part, the profit equation is simply 4 for x plus 3 for y. So that's how simple the profit equation is. Then C, we need to represent our constraint graphically. So we are representing the 4 main constraints. So now we have to have a discussion on that. The first constraint you see it has to touch only the x-axis. So I'll be using the line x equal to 0. The second one, it's only having y, so we'll get the line y equal to 300. So that one is x equal to 400. But if you go to this constraint, you can see it has x and y. So if I have to sketch that line, I need to know that it must touch the x-axis and the y. So for me to know where it touches x, I just make y 0. I'll be looking for x equal to 450. And if I need to know where it touches y, I make x 0. I'll also be looking for y equal to 450. So that line must touch both x and y. Then the stubborn one is this one. You see it's also touching x and y. And if I make x 0, y will be 0. So such a line will usually pass through the origin. Then if I need any other point where the line passes, the best thing will be to go to your x-axis and search for any number for x. You put there, you will get the corresponding number for y. So with level 4, the graph page is always given to you. So if I'm looking for a point where this line will pass, I can just choose to pick any point on the x-axis. I've got 50, 100, 150, 200. Let's say I choose to pick 200 for x and substitute into that equation. My equation is y equal to 5 over 4x. So if in the place of x I put 200, this means I'm having 200 times 5 is 1000 over 4, which gives me 250. So therefore means this line should pass through the point 200 for x, 250 for y. So that way, if I'm plotting the last line, y equal to 5 over x, 5 over 4x, I'll look at the origin. Then I'll also look at 200 for x, 250 for y. So 250 for y is somewhere there, between 200 for x. So that's how my line should look like. So I've decided to draw that line first. Then I'll call it the line y equal to 5 over 4x. So that is the most difficult line. Then I can go to the easier ones. X plus y equal to 450. I'll look for 450 on the y, just as I explained there, and 450 on the x. Then I'll use my ruler to link the two. So that is what I get. Then I label it x plus y equal to 450. Then the next lines, these ones are now easy. Y equal to 300. It's a horizontal line passing through 300, touching the y-axis at 300, which I will call it y equal to 300. Then the last one is x equal to 400. 400 is here. It's a vertical line touching the x-axis only at 400. So that is it. This is x equal to 400. So I have managed to plot all my 4 lines and I've labeled them. So that is it about C. What we've done there is C. We can now switch over to D. So usually when you plot your lines, you expect you to identify the physical region. The physical region, usually the easiest thing is to see the region surrounded by all the 4 lines. So if I were to label this one as 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then I will start by eliminating all the regions that are surrounded by the 4 lines. So a region like 1 has only 2 of the lines, so I'll take you out. 2 has 1, 2, 3, I'll take you out. 3, I also take you out. It's only 3 lines out of 4. The same thing with 4, it's only 3 lines. Then 9 is only 3, I'll take you out. 10 is only 2, I'll take you out. 7 is 3 of the lines, I'll take you out. 6, 1, 2, 3, I'll take you out. Then 5, I take you out, you're only 3, so you see that my physical region should be 8. So that's how easy it is to get your physical region. So I can just shape that region and call it my physical region, where I will put coordinate around it. A, that is B, this is C, and that is D. So whatever thing we're doing, our target is this physical region. So we can now go to D, which says draw a search line on the graph. So a search line is drawn using our profit equation. So we have to go through our profit equation and make y the subject. So I'm doing D there. My profit equation is P equal to 4x plus 3y. So I have to make y the subject. So 4x goes to the left. I get 3y, and I divide each term by 3. So I get P over 3 minus 4 over 3. X is equal to y. Then if I read my gradient from this equation, my gradient m is a change in y. If I change in x, I always like this definition because it helps me know that if I'm drawing a search line, I look for 4 on the y-axis, matching 3 on the x. I know it's a negative, but we'll concentrate on the magnitude. So to draw the search line, I need 4 on the y. You see the y-axis does not have 4, x does not have 3. So you can adjust this a bit, maybe by just multiplying by 100 each, because you see the numbers are in terms of 100. If I multiply by 100, I will get 400. Then I multiply by 100, I will get 300. So my search line means I go to the y-axis, I search for 400. That is it there. Then to the x, I search for 300. Then I can link them with a straight line. So I hope my line is straight. I make it broken line so that it should look different from the others. So my search line is something like that. And guys, we need a ruler so that this can be perfect. Unfortunately, I don't have a ruler here. So that's my search line. And I always say, if you make them many, it's fine. It will help you see the point of maximum better. But I think 1 here is enough. If this search line is moving into the physical region, you see that it will touch B first, then touch C, eliminate A, then D will be a point of maximum. So for maximum profit, we need the coordinate of D, minimum, we need the coordinate of B. So that's how a search line works. If you draw more of them, you will see better. So we've done our D part, which says draw the search line. Then it says use the search line to determine how many bunches of each type of vegetable must be sold to maximize profit. So we now see that to maximize profit, we target the point D. And our graph is easy because the coordinate of D you can read from the graph. Where you see D, if you go down, you will get 400. And if you go across to the y-axis, you will get 300. So with a good graph, you can pick that out. So it means our E means x is equal to 400. We need 400 bunches of spinach, and y is equal to 300 bunches of carrot. In the last part, we need to determine the maximum profit, which is f. We go back to our profit equation. We take 4, multiply by x is 400, plus 3, we multiply by 300. 4 times 400 is 1,600. Then plus 900, I guess that should give us 2,500 if I'm still, my mathematics is still that good. So guys, that is how linear programming works. I hope this helps as well. Thank you very much.